Hello guys. So yesterday I participated in Biweekly contest 125, but I was not able to solve third and fourth question because I stuck at third question, and there was one error, or it's like there was confusion between my logic, and I will explain that one also. But I will explain all the fours. I just solved all the fours. It's like rest of two I solved now. I will explain. So do follow us on Instagram, and we will upload core forces rounds also and centrics. So we will go to first question. Minimum option operations to exit threshold value 1. So in this question, so basically in first question, what is there? They have provided one num like 2, 11, 10, whatever, and 1, 3, and one case value is already given. So this question, what they are asking, we can, in one operation we can remove the smallest value. We can remove the smallest value. So they are asking that how many operations we need to perform to make all the elements remaining in this array will be greater than or equal to the k. Then equal to the k. So basically, just in one first operation you can remove 1. In second operation you can remove 3. In third operation, it's like in that sequence you can get what I am saying. So it is basically just asking that you need to remove the smallest one unless the answer is all the elements are greater than k. So what I did, I just shorted these values, and I'm just traversing until num_psi is not equals to or greater than k. Means like suppose I shorted this one 10 and 11. So now k is equals to 10. So what I am doing, I'm just traversing 0, 1, 2, 3, 4. This is not greater than or equal to, this is not, but when I come to this position, it is equal. So from this one above, all the conditions satisfying. So previously how many elements are remaining? So only this index is remaining. Like this is 0 base indexing, so we can return the I. So I return that, and the answer is getting accepted. You can check out, it's accepted. Let's go for the second question. We will go to second. Minimum operation, same, just higher version. In this question, what they are asking, in this one, in place of 2, like in place of 1, like they have provided 1, 1, 2, 4, 9. I will take this one 1, 1, 2, 4, 9. In this one question, what they are doing, they are saying that we can remove two smallest numbers, like is already shorted one. So we in one operation you can take first two smallest numbers, and in that operation what you will do, you will perform this operation in which you will take mean between these two. Means obviously this first will come first, plus mean multiplied by 2, and max plus max between this, which will be 1. So this value will 3 come. Now you will remove all these 2, and this 3 whatever coming you will push back into 3. So the new array will be 2, 4, 9 and 3. So this will be the new array. So now they are saying that you need to remove the you need to make all the elements of the array unless all the values remaining in the value will be greater than or equal to k. So they are already providing the k inside this one. So now let's think some approach. What I thought in that question, I thought let's take priority cube, in which we will get minimum value in log n time. Check if there will be any error, if whatever I am saying and it is wrong, just do comment in the charts, which will be helpful for others also to understand if by mistake I said anything wrong, or I said wrong. Now what I did, just I declare one priority cube, in which what will happen, firstly initially we will push all the elements, and it will be in decreasing order, like it will give in ascending order, like it will give numbers in ascending order. So in that I'm just pushing all the numbers firstly in starting, and then I'm just counting that how many operations we will require to perform. In that one, what I'm doing, I am doing this thing until unless the p top, means like the value of the priority cube top will not equal to this one, equal to k. I am buffering up to this one. Firstly, what I am doing, if it is smaller than k, then we will go to the priority queue, and we will take the first two elements. Like for that reason, I am using here first p top. Then I'm just popping out that one value. When I pop this one, I will get the next smallest number. Then I will take in that one in another. I'm just popping out. Now I will push again this product, like whatever the condition they mentioned, I'm pushing back into the back. Now again the same thing will continue until unless this value will not satisfy, and we will get the answer in the return. So basically this was the question, and this was the answer which I solved in my way. If you have any optimal way, you can tag that link in comments also, others can see easily. I'll submit, so it's going to be accepted. Now we will go to the third. I spent a lot of time on that question, and because of that my contest was not good last day. So in this question they are asking, it was third question that they are asking, count the pairs of Connectable servers in the weighted tree network. So in this question they are asking, you have provided one tree like 0, 1, 2, 3, 4, 5, and you need to go from A to B. You need to go to B, YC. This is the condition. You need to go by C, then you need to go by B. This is the condition. And they are asking, there are two conditions, that when you go from A to C, that A should be smaller than B, and the path sum, A to C sum, is divisible by, means reminder should be with respect to that one signal speed, it should be equals to 0, and same with C to B equals to signal speed. Well, let's say signal speed equals to k, so it will be k. So A to C and C to B, summation of path will be divisible by the signal speed variable, like I had defined here k. So they are asking this question. So now let's think two approaches, observations. Let's think some observations. Here first observation, you need to traverse all the possibilities, because there is no any condition for C, and C is not equals to B. It's already mentioned C is not equal to both of them. So you need to traverse all the possible pairs. Like you can travel from 0 to 1, 0 3, you can check. So but here condition is like n is up to 1000, so you the code will run up to n square. So we will get that idea that we can traverse from each node. But now here think like weighted sum is already given, like you are given ages and their weights, like their weights are given already, 1, 2, 3, 4, 5, it's already provided. So you know that suppose if you start at here, you use DFS, then you can go up to this one, and you can go up to 4 also by taking sum from 0. I am just giving one example of 0 only. You can take example of rest of things also. You can go up to 4, you can go up to 5, you can go up to 3, but you will not know that how many C's will be in the path which will satisfy this condition, because you know sum up to this one, and you know sum up to every point from that 0. So for that I will explain one concept. Suppose A plus B, here is a reminder by k equals to 0. Okay, like this condition is there, means like a plus b reminder reminder k equals to 0, and suppose a percent k. So we will just modify this one. So at the end this will be like a percent k plus b percent k, and this will be whole percent k. Like see, in this question, suppose this one a is distance from a to c, and this is distance from a to b. This is from a to c, this is from a to c, this is from c to b. Now suppose a to c is divisible by k, obviously this condition should satisfy, means a to k should be divisible by 0. This is given already. Then obviously this condition will also need to be 0 to get this condition to be fulfilled. So at the end we should know that how many points are in between path which are giving reminder as a 0 when with respect to k. So we need to find out these points only. Now in this path I will explain how I thought that answer, but what was my mistake. I was not able to implement because I thought it will be give it will in return time it will give me the proper answer, but it was wrong approach, it was wrong implementation. So now and this is 2. So we will take the values 3 1 2 7 1 2 6 and 7. These are the whole values, and this is 1, I guess. Yeah, this is 1, this is 1. Just understand here, because now in this example which are getting the answer, okay, pairs are 4 5 and 0 to 5. Okay, I will explain now. See, suppose if you try to run by 0 and where is k is like signal speed is 3, signal speed is 3, signal speed is 3. So now we will start from 0. Now 0 to when we come to 3 6, the total path sum is 3. Now 3 is divisible by signal string and it is giving reminder 3, so we will mark as 1. Now when we come to 5, the total path sum is 6, so it is divisible by 3, so we will mark as 6. Now there is nothing. So let's think, when you come to this point, that time you are getting that when you come to 0 to 5, there are 2 positions at which the path sum is getting 0, giving reminder as 0 with respect to signal speed. So at the end, out of this, it's like out of this n minus 1 will be the, you can choose as your C. Like there are choices that you can choose among these points, that these are your C's. So and that if you choose 6 as your C, then you can come up to this one and you can go up to this one, because the summation will be, total reminder will be as usual. Suppose there are 100 points are there, similar thing will happen, that you will come up to this point, but the reminder is 0, so some condition is fulfilling, and the other positions where the sum condition is also fulfilling, and along with that this condition is also true, that A is smaller than B. So we need to find out those points only. But now there is one trick, you can't find out when you go when you come from the top down one. When you come top down when you come from top to down, that time you will not able to count this one. You don't know how many positions for this 6 are below, which are satisfying, like the reminders is giving 0 for these 6. For 5 you don't know. Now for that reason what we are doing, so I am here using So firstly I'm declaring an adjacency matrix. Then I'm just making one array count pair size, where we will count only C, how many C's are there, in which below how many below the positions are available, which will fulfilling that we can use C or 6 as a answer for that all the positions. So for that reason I am using count pair resize.n dp size, and here visited for not coming back, because it's not one way, it's two way given position. So once we come from here down, we will not we don't require to go back. It's like traverse one time only. Then I'm doing dp. Why I'm doing, I will explain why I stored dp here. So basically 1 2 3, and suppose here 5 is there. Suppose I am coming from this one. I know here is position 1, here is position, here is position 1. So suppose 3 5 6. So for this point, if suppose here is also getting the remainder 0, here is also getting remainder 0, here is also getting remainder 0, here is also getting remainder 0, here is also getting, this was my logic. This thing I missed during contest time, that this thing can also be occur in our traversing. I thought only this way, but this thing will be also occur. Suppose this thing will also getting remainder as 0. So for this point to consider as a C, how many positions are below? So this point also, this point also, this point also, this. So there are 4 possibilities, for 4 paths from 5 to above are there, which in which one will play as a C role. Similarly, so for this condition, what should we know? You should know how many paths are okay, how many positions are okay below. That will satisfy this as a C condition for 5. So for that reason we are storing in dp, we are just storing how many position below of this one are okay, that satisfy this condition. So from this one, how much, for this one how many are there? 1. For this one how many are there from this side? 2. From this one how many there are? 1. For this one here is 1. For this one here 2. So at the end 2 plus 2 it will be 4. So this was the dp. So now dp, and we are just using dfs for every node. I said you need to traverse from every node. So basically you will traverse from smaller to larger number, because you need that one at the end, 0 to b. So now this one is done. I'm just storing the signal speed, and just sum at the end, you know, sum you need to go traverse down. So now here I'm just making marking visited as a 1. Now I'm just moving down. If suppose this is already visited, we will continue, we will not go again. So I'm just moving forward, that I will go to the next node. Suppose 1 is there, 2 is there, 3 is there. I'm just in starting, I'm just counting whether this is okay. No, I'm not anything, I'm just doing, I'm just going forward. I'm just going forward with respect to weighted sum, like this is 5, this is 5, then I'm just taking as a 5 here, I'm moving with respect to 10 here. Now when the loop gets over, like this 3, there is nothing we can go in dfs, we comes out, that time we check if the sum for this one, sum is giving as a reminder 0, and the sum is greater than 0, because at the end when you return back, 1 will gain counted if sum will be equals to 0. So we don't want to consider that case also. For that reason we are just moving, we are just considering this case also, sum equals to 0, sum should be greater than 0. If it is fulfilling this condition, then we will add up the dp values. As I said, we will add up that dp values from below, whatever the values coming, we will add up in this one, because we can make C as we can make that node as a C, because we know that the sum will be 0 for this node only. For this node there will be no sum. So we will perform this operation of addition of making C up to next node of whatever your starter node, So now here I'm just making this one, I'm just adding that one in that make, because we can make that dp node equals to 0, equals to that C. Now what I will do, when I perform this operation, now I will, for returning back, I will check whether this node is also able to make that condition of sum equals to 0, if and sum should be greater than 0, and to make this node to be, see, first condition, to make this node to be b. So in dp, what I am storing, in dp I am storing how many possible b's are there, how many possible b's are there below that node, how many possible b's are there below that node. I am just adding that one, and in for making c, I am just adding how many b's are below that one, how many b's are below that one. So suppose here 1 is there, sorry, I will not use green color here. Okay, done. 1 is here, 2 is here, and 3 is here, and 4 is here. So for 3 I am checking, like in 3 the answer is getting reminder 0, because we are coming from 1, the answer is getting 3 as a 0 here. So we will check how many b's are there which are fulfilling this same condition, like they are getting 0 with, they are giving reminder as 0 with respect to signal speed. I am adding that b's into this one, because we can make c for all the below b's. Now for again, after performing this operation, I am checking whether this thing is also satisfying the condition for to be a b for the above nodes. So for this, I am just checking node should be greater than equals to start. If it is, then I am just adding with respect to +1 in that one, and same I am moving above. And at the end, we will go for all these values. You need to update dp for every time. So for that reason, I am just assigning, because this is the condition for this one. For rest of condition, there will be different conditions. Visited will be, you need to update all time, and this is the answer. I will submit. I hope you understand this question and it is accepted. I just missed by mistake. I thought I was not able to think about that edge case. We will go to the last question. So in this question, find the maximum sum of nodes of node values. In starting, I thought by DFS, but later I got that the question is little bit logical, not so. So basically, they have provided nodes, one tree to you. So think like this way, and in one operation, what you can do, you can take any edge and you can change the values between for the respective nodes to the with respect to XOR. This is the condition, and they are asking that you need to give that how many maximum sum of all the, like after performing all the operations, what will be the maximum sum you can return, you can give back, you can return. They are asking this question. So so this is the question, that how much maximum sum of all the elements after performing this all the operation on the tree you can return. So firstly, I will explain some XOR concepts in which you should know that when you do XOR with own number, like 1 equals to 1, it will give 0. With respect to 0, it will give 1. 0 with respect to 0, it will give 0. 0 with respect to 0, it will give 0. So these are the three properties of XOR. Now think, suppose there is one tree and now you should know that when you do XOR with XOR number, it will give 0, but you do even odd times, it will return as usual the number. You should know this thing, that when you do XOR with XOR same number, it will give 0, but when you do triple times, it will give that number as usual. So suppose there are, how many edges are there? 1, 2, 3, 4, 5. Now in this question, suppose if you perform XOR on this number, and when you perform XOR on, like now I will explain by different color. So now when you perform XOR on this number increase. Okay, this number increase, suppose 4. This number is not increased. But when you perform XOR on this number, it will be increased. And this number, as you XOR with 2 times, like XOR k into XOR k again, then it will become again 1. It is increase. Similar thing when you do, it will again give decrease. It will do again, it will remain as usual 1. So at the end, if you perform any operation on any number, if it will be even times, the number will be remain as usual. If it is odd times, the number will remain in the converted form. So there are a lot of choices that you can change anyway, like suppose 1 2 3 4 5 6. Like suppose if you want to change only this number 6, as you want to only change, but you don't want to change 5, but you can what you can do, you will perform an operation on 5 and 6, then you will perform any one operation on 3 and 5, that 5 will get restored again. Then you will perform any, like if you want to change only 2, or if you don't want to change 3, then you will again perform any operation on 3 and 4, and you will keep 3 as usual. And if you want to perform operation on 2, then you will do, and you will just keep as it. If you want to perform operation on 1, and that you don't want to perform operation on 2, you will again do with respect to this one, you will change 1, but you will keep 2 as, because you are doing even times operation on 2 and 3 and 5, it will remain as usual. If you don't want to change 1 and 2, but if you want to change 4 and don't want to change 3, then you will perform operation on this one. So these are a lot of options you can do, where you can choose or not choose. So how you will think that you want to change or not change any single number, like from that ages. So basically the concept is, if a number XOR with respect to any number giving value greater than that number, that will be only benefit for us. And remember, just think of, okay, only when you perform a XOR, k XOR with any number, and that is giving number is greater than, because equals to doesn't matter that there. So we can take equals to x. We will check in the code what I mentioned. Yeah, we should require greater than. If it is giving greater than, then and then only we will perform that operation, and we will count how many operations we required over there, because at the end we need to change only these numbers. And I have shown that you can change any number by again doing that operation on that number, like even number of times. So we need to only check how many numbers are there which will give values greater than their respective values. But there is one twist, that suppose there are even numbers, then you can take 2 2 2 2. But suppose there is one odd position, like odd numbers are there which are giving this condition. In that condition, we need to choose such a number, such a value which will get decreased down. So for that reason, we will check how many numbers are there. Which are giving value greater than this one, and how many counts are there. And we will check, if suppose we remove this value, suppose we will take XOR again that, then we change that value, how much difference will require to change. So for that reason, what I am doing, so basically this is not like DFS BFS question, it is just like logical question where you need to think about this approach. So in this question, what I did, I just consider log and some count, one temporary variable, where I will check which value, suppose there is odd condition, then which value should we get removed from that total sum which will be we will count. So here I'm just doing XOR, like this XOR value is greater than x, like nums, then just I'm adding up. Now I'm checking, suppose I wish to remove this number, suppose there is odd numbers of times are there, and I wish to remove this number, then what I will do, I will just check how many minimum difference from these two numbers are creating. Like suppose after XOR answer is 4 and actual value is 2. So difference will be 2. So suppose you need to remove such a number, the minimum number is 2. So in our answer we added 4. In our answer we added 4, but the actual wish answer should be 2. So for that reason I am just removing 2 from the last number. If there will be odd count, because 2 pairs we can choose a single time, we need to sacrifice one number. So here I am just counting how many numbers are like this way. Now else what I am doing, suppose the number is not getting, then we need to add as usual we need to add that number. And also we will check, suppose in that number also suppose one number is there, we'll check. Suppose we do XOR of that number for if there is odd count, if suppose 1 2 3. So suppose in this one there are three positions. Suppose what we will do, suppose these two numbers are okay, giving maximum value, and this is not giving us lesser value. So I will add 1 also. These three values are giving maximum value, and this thing is like this way. You will just understand, I hope. So here these things are giving maximum value, but this is not giving any maximum value, it's giving lesser value. In that case also we will check whether, suppose we will XOR this value and we will XOR this value. In that case if we do XOR this one, how much maximum value will change. So we are also checking here how much the difference we will change. We require minimum difference to be changed in the answer. And suppose if these values are like, suppose there is 4, this one 5, these are the even values, like 4 values are only need to change, then there is no any point of view to decrease anything. So we are just returning that answer. And suppose there is only odd count where this value is increasing, we are just returning the sum minus temp. Temp means that minimum value difference we need to remove from the sum. So this was the answer. I hope this is accepted. If you have any doubt, you can comment below. If you like my videos, please subscribe to the channel. I will improve definitely day by day. Thank you guys.